quadrant trigonometry. All right, let me put in our space. Now, as I said earlier, the last time we met, we looked at the first two triangles, right angle triangles, which was the 30, 60, and 45. Today, we're going to start looking at the 0 and 90. Now, for us to look at 0 and 90, the first thing I need to do is I need a drawing. I have to use the first quadrant of a Cartesian plane. Now, we are dealing with what is called a unit circle. So it's like taking a part of a circle. And if you'll notice, when I'm drawing, this is O, which is the center, this is A, and this is B. So the angle in question is theta here. Note that OA is the radius of the triangle, and AB is the value of Y, and OB is the value of X, or the X coordinate. Okay, so that means that this point here is what we normally call XY. This line here, the Y, is actually the opposite. This one is hence the adjacent, and of course the R is the hypotenuse. Any questions up to there? You understand what I've said just now? Yes? Novella, you with me? So, but obviously, it should be obvious that this angle right here is not 0 degrees. It's not 0 degrees. And this line here, this curve, is as far as A can go. So A cannot go any, will always land on this curve. So it can't get bigger, it can't get smaller, it must remain on that curve. So I need this angle theta to become 0. To do so then, I will cut it in half, and for me to show the difference, I'm going to put it in a different color. So I'll cut it in half. And so this point is still A, so that's A prime, and that is B prime. So this is a new theta right here. It should be obvious to you that that is still not 0 degrees, right? But we're getting close. So I'm going to cut this in half again. So this is A double prime and this is B double prime. Okay? And again, I'm getting close, but I am still not at 0. And I need it to be as close to 0 as I can possibly get it. So I'm going to cut again this angle in another half. So that's A triple prime and B triple prime. Now, having done that, I can see a pattern now. What is happening to AB? Can somebody tell me what's happening to AB? What's happening to AB? Is AB getting bigger or is AB getting smaller?
Smaller, sir.
Smaller, so it's decreasing. So it is decreasing and it will keep decreasing. All right, it will decrease until it reaches a particular value, and that value will be 0. It won't be it because that line has to reach right here horizontally for the angle to be 0. Okay, now what's happening to OB? What's happening to OB? Is it getting smaller?
Getting bigger, sir?
It's getting bigger. It is increasing, and it will increase until it becomes what? What do you call the distance between the center of a circle and its circumference?
Fine. Mo fine.
Radius.
Radius. So it until it becomes the radius, which of course we call it OA, then that is when OB will stop growing. Okay? Because remember, it can't get bigger than OB. It can't go outside the circle. So now that we know this, that means that the opposite will be 0, will end up at 0, and the adjacent will end up being OA. Okay? So now we can work this out.